Hello everyone, welcome to ACE Maths. In this video, we are going to solve 10 exam style questions on Surds, exactly at the level you can expect in IGCSE 0580 extended. Before I solve each question, I suggest that you pause the video and try to solve it on your own. So let's begin. Let's solve our first question. Here we have root 75 minus 2 root 48. First, simplify each surd. So we have root 75, right? Root 75. We already know how we can simplify a surd. For that, we need to find factors of that surd, and one of the factors should be a perfect square. So I can write 75 as 25 times 3. 25 is a perfect square. So square root of 25 is 5. And we have root 3. So root 75 can be simplified to 5 root 3. In the similar manner, let's simplify square root of 48. Again, I can write it as 16 times 3. Square root of 16 is 4. So I can write it as 4 root 3. Now let's go back to the original question. We have root 75 minus 2 root 48. After the simplification of the surds, the expression becomes 5 root 3, that is root 75, because root 75 is 5 root 3, right? And then we have this negative sign and 2 multiplied by square root of 48. Square root of 48 is 4 root 3, right? So let me just write 4 root 3 here. Now let's simplify. We have 5 root 3 minus 2 times 4 is 8, 8 root 3. Okay, so these are like terms and we know how we can subtract. We only need to operate on the coefficients, that is 5 and 8. So 5 minus 8 is negative 3, negative 3 root 3. All right, so this would be the final answer. Moving on to the next question. Here we need to arrange some numbers containing surds in descending order. And note that we are not allowed to use a calculator. Let's first ask ourselves, are these numbers already simplified? So we have 3 root 6. Can we simplify it any further? No, because root 6 is already in its simplified form. So we cannot do much with 3 root 6. But here we have square root of 24, and we know that we can simplify square root of 24, right? What about 4 root 6? Again, 4 root 6 is already simplified. So we need to think about root 24. So let's take root 24 and let's try to simplify it first. Root 24 can be written as square root of 4 times 6. And look carefully that I have factorized 24, and one of the factors 4 here is a perfect square. So I can write it as square root of 4 is 2. So 2 times root 6, that is 2 root 6, right? So now we have 3 root 6 and root 24 is 2 root 6 and 4 root 6. So are we able to now arrange these numbers in descending order? Yes, we are. Okay, so this 4 root 6 is clearly the largest number. So let's write 4 root 6. Then we have 3 root 6, that is 3 root 6. And then we have 2 root 6. So 4 root 6 is greater than 3 root 6 and 3 root 6 is greater than 2 root 6. And that is the descending order that we were asked to write. Moving on to the third question. Here we need to simplify an expression and the expression contains a bracket. So this 5 root 2 is present outside the bracket. That means that I need to multiply this 5 root 2 with root 5 first. That would be the first multiplication. And then I need to multiply this 5 root 2 with negative 2 root 2. And that would be the second multiplication. So let's do the first multiplication. We have 5 root 2 multiplied by root 5. Alright, I can write it as 5 times square root of 2 times 5 using the laws of surds. That is 5 times root 10. And I can write it as 5 root 10. Now let's do the second multiplication. We have 5 root 2 multiplied by negative 2 root 2. Alright. Okay, I can place this negative sign at the beginning. It does not change the value. 5 root 2 is 5 times root 2 and 2 root 2 is 2 times root 2. So let's multiply. We have 5 and 2. 5 times 2 is 10. Don't forget this negative sign. And we have to multiply this root 2 with this root 2. Alright, so root 2 times root 2 is simply 2. So minus 10 times 2 is 20. So that is the result of the second multiplication. Now let's go back to the original question. We have the result of the first multiplication. The result of the first multiplication is 5 root 10. So let me write 5 root 10. And now I will write the result of the second multiplication. The result of the second multiplication is negative 20. So 5 root 10 minus 20 would be the final answer. Now moving on to the next question. Here we need to multiply and divide some surds. Let's see how we can solve this. Okay, so here in the numerator we have root 10 times 3 root 5. So I can just simply write it as root 10 multiplied by 3 multiplied by root 5. Alright, and in the denominator I can write 5 root 2 as 5 times root 2. Now let's multiply. In the numerator we have root 10 times root 5. So that is 10 times 5 in the same square root symbol, and then we have multiplied by 3. And in the denominator we have 5 times root 2. Now in the numerator we have root 50. 10 times 5 is 50. 50 multiplied by 3, and we have 5 times root 2. Look carefully that here we are dividing two surds, right? So I can write it as square root of 50 over 2 multiplied by 3 over 5. I can carry this division operation under the same square root symbol using the laws of surds. 50 over 2 is just 25, right? And then we have 3 over 5. Square root of 25 is 5. 5 times 3 over 5. I can cancel these 5s and I will be left with just 3. And that would be the answer of this question. Let's solve our fifth question. This question is quite similar to the previous question we just solved. Okay, so here again we need to multiply and divide surds. In the numerator, I can write it as 5 times square root of 7 into 3. And in the denominator, we have the square root of 28. Okay, let's simplify. So 5 times square root of 7 times 3 is 21 divided by square root of 28. Again, we are performing this division operation, right? So I can put a square root symbol and carry the division under it. So I can write 21 over 28. Now 21 and 28 both have 7 as the common factor, right? So here we will have 7 times 3 is 21 and 7 times 4 is 28. So I will have square root of 3 over 4. Now I can write it as square root of 3 over square root of 4 using the laws of surds, and we know that square root of 4 here, square root of 4 is just 2. So let me write 2 in the place of square root of 4. And now I think we cannot simplify it any further. So I will just write 5 root 3 over 2. And this would be the final answer. Moving on to the next question. Write in simplest form with a rational denominator. So basically we need to rationalize the denominator in this question. If we look at the denominator, we will find root 2. Root 2 is a single surd present in the denominator. So whenever we have a single surd present in the denominator, we multiply the numerator and the denominator with that surd. So what should I do? I will just multiply this fraction with root 2 in the top and in the bottom. Okay, so now let's solve the numerator and the denominator parts separately. So in the numerator, we have root 2 multiplied to 2 root 2 plus root 3. We already know how we can solve this. First, we need to multiply this root 2 with 2 root 2. That would be the first multiplication. And then we need to multiply this root 2 with root 3. That would be the second multiplication. So we have root 2 multiplied by 2 root 2. That is the first multiplication. Let me write it as first. And then we have the second multiplication. Root 2 times root 3 is plus root 2 times root 3, and this is the second multiplication. Now let's solve this expression. Root 2 times root 2 is 2, and 2 times 2 is 4. So the result of the first multiplication is 4. And here we have root 2 times root 3. So that is root 6. That is the result of the second multiplication, 4 plus root 6. Now let's solve the denominator. In the denominator, we have root 2 multiplied by root 2. Root 2 times root 2 is simply 2, right? So we have the numerator and the denominator. So the original fraction, that was 2 root 2 plus root 3 over root 2, can be written as the new numerator is 4 plus root 6 and the new denominator is 2. Look here that in the new fraction, the denominator is a rational number, so we have removed all the surds, and that is why this would be our final answer. Let's solve the seventh question now. Here also we need to rationalize the denominator, but there is a significant difference. In the previous example, we have a single surd denominator, but here we have a two-term denominator. It means the denominator contains two terms, root 3 and root 7. To rationalize a two-term denominator, we first find the conjugate of the denominator. So the conjugate of the denominator is 3 plus root 7, right? Because the denominator is 3 minus root 7. So the conjugate would be 3 plus root 7. So to rationalize the denominator, we need to multiply this fraction with the conjugate, that is 3 plus root 7. Alright, now we need to simplify this fraction. We will simplify the numerator and the denominator separately, and then for the final answer we will combine them into a fraction. So let's first solve the numerator. In the numerator we have 3 plus root 7 multiplied with 3 plus root 7, right? So this is basically 3 plus root 7 whole squared. We can solve this using a very famous algebraic identity. Can you guess? That is a plus b whole squared. We know that a plus b whole squared is a squared plus 2ab plus b squared, right? If we compare it with the original question, we have 3 in place of a and root 7 in place of b. So using that, we can expand this expression. It would be a squared. So we will write 3 squared plus 2ab. So I will write 2 times 3 times root 7 plus b squared. That would be root 7 squared in our case. So 3 squared is 9 plus 2 times 3 is 6, and 6 times root 7 is 6 root 7 plus root 7 squared is 7. Now I can add these terms. 9 plus 7 is 16 plus 6 root 7. Since these are not like terms, I cannot add any further. So this would be the numerator. Now let's solve the denominator. Okay, so in the denominator, we have 3 minus root 7 multiplied with 3 plus root 7, right? Here I can simplify it using another algebraic identity. A minus b multiplied by a plus b is a squared minus b squared. If we compare it with the question we have in hand, we can find that this 3 here is actually our a and this root 7 is b. So we had a minus b and here we have a plus b. So if we use this algebraic identity, I can rewrite it as a squared, that is 3 squared in our case, and minus b squared, that is root 7 squared. 3 squared is 9 and root 7 squared is 7. So 9 minus 7 is 2. So here we have the denominator. Now let's rewrite the fraction. In the question, the fraction was 3 plus root 7 over 3 minus root 7, right? And after the rationalization process, the new numerator is 16 plus 6 root 7 from here, right? And the new denominator is 2. Now, can I simplify it further? I think I can, because if you look at the numerator, you will see 16 and 6 root 7. I can factor out 2 from there, right? So if I factor out 2, I will have here 16 divided by 2 is 8 and 6 divided by 2 is 3. So 3 root 7, and in the denominator I have 2. Now I can cancel out these 2's. So I will have 8 plus 3 root 7, or you can put this 1 in the denominator. So if we look at this answer that we have a rational denominator. There are no surds present there. So we have successfully rationalized the denominator. Now moving on to the next question. Here we need to write this expression as a single fraction with a rational denominator. This question may look complex, but the rules are the same. On first glance, we can see that here we need to add two fractions, and in both the fractions we need to rationalize the denominator. All right, so I can name this fraction as the first fraction, and I can name this one as the second fraction. So now I will handle the first and the second fractions separately, and at the end I will just add them up to find the final answer. So let's talk about the first fraction. All right, so the first fraction is 3 plus 2 root 7 over root 7 minus 2. Clearly, I need to rationalize this fraction, right? So if I rationalize the denominator, I need to multiply with its conjugate. The conjugate of root 7 minus 2 is root 7 plus 2. So let's just multiply with root 7 plus 2 at the top and here at the bottom. All right, now let's multiply. So in the numerator, we have 3 plus 2 root 7 multiplied by root 7 plus 2, right? And in the denominator, look carefully, I have what you call the algebraic expression a minus b times a plus b. That is nothing but a squared minus b squared. So I can write it as root 7 squared minus 2 squared, right? Now let's solve the numerator. To solve the numerator, we first take this 3 right here, and we will multiply this root 7 plus 2 with it. So let's take 3 and multiply root 7 plus 2. Alright, now let's take this plus 2 root 7. Let me take plus 2 root 7 and then multiply it with root 7 plus 2. That is the law of distribution. Whenever we have two brackets, we multiply them using the law of distribution. Now in the denominator, right, in the denominator we have root 7 squared. Root 7 squared is just 7, and then we have 2 squared. 2 squared is 4. All right, now let's see what we can do in the numerator first. Here clearly we need to multiply this 3 with root 7 first, and then this 3 with 2. Here 2 root 7 will be multiplied to root 7 and also to 2, right? So here in the numerator, 3 multiplied by root 7 is 3 root 7. That is the first multiplication. And then 3 times 2 is 6. That is the second multiplication, right? Now 2 root 7 into root 7. Root 7 times root 7 is 7, and 7 times 2 is 14. So that is the third multiplication. All right, and let's multiply 2 root 7 with 2. So 2 root 7 multiplied by 2 is 4 root 7, and 4 root 7 is the answer of the fourth multiplication, right? So we have already simplified the numerator. Now let's talk about the denominator. Quite simple, right? 7 minus 4 is 3. Now let's search for the like terms in the numerator. Can we find some? Yes, we have 3 root 7 here, right? 3 root 7, and we have 4 root 7. Clearly I can add these terms. 3 plus 4 is 7, so let me write 7 root 7. And then we have 6 plus 14 is 20 over 3. So 7 root 7 plus 20 over 3. That the first fraction can be simplified to this. All right. Now let's take the second fraction and see what we can do with it. So now let's solve the second fraction. This is our second fraction. And first we need to simplify it. If we look closely, we can see that we have a root 12 here, right? Root 12. Root 12 can be simplified. Root 12 is actually 2 root 3. So we need to replace root 12 with 2 root 3 so that our simplification can become easier. So 2 root 7 in the numerator, and in the denominator, in place of root 12, I will just write 2 root 3 plus 3. Alright, now we need to rationalize the denominator. To rationalize the denominator, we need to find the conjugate. The conjugate of 2 root 3 plus 3 is 2 root 3 minus 3, right? So let me multiply this fraction with the conjugate, that is 2 root 3 minus 3 over 2 root 3 minus 3. Now let's simplify the numerator and the denominator. So in the numerator, I have 2 minus root 7 multiplied by 2 root 3 minus 3. Alright, and in the denominator, I have 2 root 3 plus 3, 2 root 3 plus 3, and multiplied by 2 root 3 minus 3. Okay, so let's first talk about the denominator. In the denominator, if we look closely, we have an algebraic expression of the form a plus b multiplied by a minus b. We know that this is actually a squared minus b squared. So with that in mind, let's rewrite our fraction. So in the denominator, we will have a squared. So we have 2 root 3 in place of a, 2 root 3 squared minus b squared minus 3 squared, because 3 is taking the place of b. So that is the denominator. What about the numerator? In the numerator, we need to multiply these two brackets, and in the previous example we saw that we use law of distribution to multiply in such cases. So first we will take 2 and multiply 2 root 3 minus 3 with it. So let me take 2 and multiply it with 2 root 3 minus 3. Alright, now let's take negative root 7. Negative root 7 is present here, right? And multiply it with 2 root 3 minus 3. Again, we are using the laws of distribution. Now, in the denominator, 2 root 3 squared is actually 12, and 3 squared is 9, all right? But in the numerator, we need to solve a bit. First, this 2 would be multiplied to 2 root 3, and then it would be multiplied with negative 3. Similarly, this negative root 7 will be multiplied to 2 root 3, and again this would be multiplied to negative 3. So there are 4 multiplications that we need to perform for the numerator. The first multiplication is 2 multiplied by 2 root 3. This is the first multiplication. 2 multiplied by 2 root 3 is 4 root 3. Again, we have 2 multiplied by negative 3. The second multiplication, 2 multiplied by negative 3 is negative 6. Now let's solve the third multiplication. Here we have negative root 7 multiplied by 2 root 3. And that is 2 root 21, because we need to multiply the 7 with the 3 under the same square root symbol. And then we have the fourth multiplication, minus root 7 multiplied by minus 3. Negative times negative is positive, and 3 times root 7 is 3 root 7. All right. Now let's simplify the numerator. So in the numerator, we can see that there are no like terms. So we cannot simplify the numerator any further. So I can just write 4 root 3 plus 3 root 7 minus 2 root 21 minus 6. I have just rearranged the terms. It does not change the value. In the denominator, however, we can simplify. 12 minus 9 is 3. All right, so finally we have found the simplified version of the second fraction. Okay, now if we go back to the original question, look carefully that here we need to add the two fractions, first and the second. So to find the final answer, we actually need to add 1 plus 2. That is the first fraction added to the second fraction. Okay, so the first fraction was 7 root 7 plus 20 over 3, right? So we have 7 root 7 plus 20 over 3 as the first fraction. And the second fraction here we have found as 4 root 3 plus 3 root 7 minus 2 root 21 negative 6 over 3. All right. Since the denominator is same for both the fractions, I can just add the numerators. So if you add the numerators, I can write it as 7 root 7 plus 20 plus 4 root 3 plus 3 root 7 minus 2 root 21 minus 6. All right. Now let's find like terms in the denominator. Here we have 7 root 7, right? And here we have 3 root 7. These are the like terms. We can add them up. So 7 root 7 plus 3 root 7 is actually 10 root 7, right? And then we have 4 root 3 negative 2 root 21, and 20 minus 6 is plus 14, right? Over 3. So this would be the final answer. I know that this question and its solution may look intimidating to some of you, and that is completely normal. If you want to practice this question, I suggest that after watching the video, try to solve it on your own. And whenever you find a step difficult to understand, pause the video and try to figure it on your own. If you still find it confusing and if you are not sure about a particular step, I recommend that you comment and I will try my best to make you understand. Moving on to the next question. Here again, we need to rationalize the denominator. If we take a glance at the question, we can see there are three surds here. First one is root 18, root 8, and root 98. Before starting the rationalization process, it's good to solve all the surds or simplify them so that later when we are actually rationalizing the denominator, the process becomes simple. So first, let's simplify the surds. Here we have root 18. All right. So root 18 is basically root 9 times 2. Root 9 is 3, so 3 root 2, right? So root 18 can be written as 3 root 2. Again, we have root 8. So root 8 can be written as 4 times 2. Square root of 4 is 2, so I can write it as 2 root 2. And then we have root 98, right? Root 98 can be written as 49 times 2. Square root of 49 is 7, so 7 root 2. If you are not very comfortable with simplifying surds, I recommend that you watch our first video on surds. In that video, I have mentioned the exact method through which we can simplify any surd. Not only that, in the video we have already solved many questions that deal with similar cases. So now let's go back to the original question. Here in the place of root 18, I can write 3 root 2, right? Because we have simplified root 18 to 3 root 2. And in the place of root 8, I can write 2 root 2 over 2 plus 3 times root 98 is 7 root 2. All right. Now let's simplify it. So 3 root 2 minus 2 root 2 in the numerator. Let's just subtract the coefficients. 3 minus 2 is 1. So in the numerator, we will have root 2. And in the denominator, we will have 2 plus 3 times 7 is 21. So 21 root 2. So now we have simplified our fraction to this. But we still have to rationalize the denominator. So let's take the fraction root 2 over 2 plus 21 root 2. To rationalize the denominator, we need to multiply with its conjugate. So the conjugate of 2 plus 21 root 2 is 2 minus 21 root 2. So let's just multiply with the conjugate. So 2 minus 21 root 2 over 2 minus 21 root 2. Now let's simplify the numerator and the denominator. In the numerator, I have root 2 times 2 minus 21 root 2, right? And in the denominator, we have a plus b multiplied by a minus b. Again, the same algebraic identity. So it will simplify into a squared, that is 2 squared, minus b squared. We have 21 root 2 in the place of b, so 21 root 2 squared. Let's solve the numerator and the denominator. Okay, so in the numerator, we need to multiply this root 2 with 2, and then this root 2 with 21 root 2, right? So root 2 times 2 is actually 2 root 2. That is the first multiplication, right, here. And then we need to multiply this root 2 with negative 21 root 2. That is the second multiplication. So root 2 times root 2 is 2. And if we multiply 2 with 21, that would be negative 42, right? So we have solved the numerator. Let's solve the denominator part. Here 2 squared is 4, and this is 21 root 2 whole squared. 21 root 2 whole squared is actually 21 times 21 and root 2 times root 2. Root 2 times root 2 is 2 and 21 squared is 441. 441 times 2. If you are not very comfortable solving it mentally, you can also solve it using the simple laws. We have 21 root 2 times 21 root 2. 21 times 21 is 441, and root 2 times root 2 is 2, and that is why I have written it here as 441 times root 2. So in the numerator, we have 2 root 2 minus 42, and in the denominator, we have 4 minus 441 times 2 is 882, right? So that is 2 root 2 minus 42 over 4 minus 882 is negative 878, right? Now, I can simplify it a bit further. Now, let's factor out 2 from the numerator. So, I can write it as 2 multiplied by root 2 minus 21, right? And in the denominator, we will have negative 878. 2 divides 878 by 439. So I can multiply this negative sign in the numerator. So it will become 21 minus root 2. And in the denominator, we will have 439. So finally, this one would be the final answer. Moving on to the final question. So this is an application based question. An engineer designed a round metal disc with an area of 236 pi millimeter squared. So there are two parts of this question. The first part asks the exact diameter of the metal disc, and the second part is asking about the smallest square area from which the disc could be cut. So let's solve the first part. The first part is about finding the exact diameter of the metal disc. The area of the metal disc is given. So the area is given as 236 pi millimeter squared, right? And this area belongs to a round metal disc. Be very careful with these descriptions. Round metal disc is actually a circle, right? So we need to write the area of a circle. We know that the area of a circle is basically pi r squared, where r is the radius, right? 236 pi millimeter squared. R is the radius of the round metal disc. First, cancel pi on both sides, right? So we have pi on both sides of the equation. We can cancel it out. So I will have r squared as 236. So r squared is 236. That means to find the value of r, I need to find the square root of 236, right? So 236 can be simplified as 4 times 59. Again, I need to find factors of 236 so that one of the factors must be a perfect square. So here 4 is the perfect square. So square root of 4 is 2 times square root of 59. So 2 root 59 is the radius of the metal disc. But we need to find the diameter, right? We know that diameter of a circle is 2 times the radius, right? So 2 multiplied by 2 root 59 is 4 root 59. So 4 root 59 is the final answer of this question. Now let's solve the B part of the question. We want the smallest square area from which the circular disc can be cut. So in this figure, the square is drawn using the red ink and the circle is drawn using the blue ink. The key idea is the smallest square that can contain a circle has its side equal to the diameter. So let me draw the diameter of the circle. Okay, so this is the diameter of the circle, and from the figure you can see that this diameter is equal to the length of the square. So in the previous example we found the diameter of the circle. So the diameter was 4 root 59, right? So the side of the square should be equal to the diameter, that is 4 root 59 millimeters, right? Now if we want to find the area of the square, we know that the area of the square is square root of the side. We know the value of the side as 4 root 59. We need to square it. So 4 squared is 16 and root 59 squared is 59. So 16 times 59 is 944 millimeter squared. So this would be the answer of this question. So that completes our 10 exam style Surds question. If you found this helpful, please like the video and subscribe to Ace Maths. Thank you for watching, and I will see you in the next lesson.